Whoops. There you go, some high-tech graphics. Nice. Right. Question number 2. Here we go. It's the skiing man. Okay, let's look at this question. Andrew skis down a hill. He starts from the top of the hill and his speed increases as he goes downhill. Okay, so his speed gets bigger, right? He controls his speed and direction by using his skis. He brings himself to a stop at the bottom of the hill. Blah, 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 blah. Describe the energy changes from the top to the bottom, starting to stopping. Easy peasy. First of all, let's draw a picture. Okay, so here's the hill. Here's the bloke on his skis at the top of the hill. Okay, and at the very top, all he has is gravitational potential energy. As he rolls down the hill, he's going to speed up and gain kinetic energy, but he's also going to lose energy because he's sliding about on his skis and using a bit of friction to slow himself down. So eventually at the bottom, he will have no kinetic energy and all the energy will be dissipated, it will be spread out, it will be converted into heat, probably be a bit of sound, etc, etc. Okay, easy peasy stuff. That's key stage 3. Right, 3 marks. Let's do an answer. Here we go. So 1. Gravitational. Let's spell this right. Yep. Gravitational potential energy is, magic word, transferred. Sorry, I've got a cold, children. Is transferred to kinetic energy. Nice, 1 mark. Right, next. What's happening? The kinetic energy gets transferred to sound. As he's moving down, you can hear the sound, and more importantly, a little bit of heat. Sound and heat. Bang. 2nd mark. And the final mark to wrap it all up. At the bottom, all of the kinetic energy is dissipated, spread out as heat. And he's at a complete stop at the bottom. Okay? Not a bad question. 3 marks. Keywords: transferred, gravitational, sound, heat, kinetic, etc, etc. Right, let's move on. Excuse me, I'm going to blow my nose. Right, here we go. Andrew returns to the top of the hill and starts again. His mass is 67. Show that his momentum is about 200 kilograms meters per second. And when his velocity is this. Here we go. Write the formula. Always do this. Momentum, mom, is equal to mass times velocity, which is equal to 67 kilograms times by 31. Get your calculator out. I've lost mine. Oh no, where is it? 67 times by 31 equals 2077 kilograms meters per second, which is about 2000. Okay. Now then, mark scheme says that you get 1 mark for doing this bit and 1 mark for evaluating. Okay. Don't miss these bits out. Always write the formula. Repeat after me. Always write the formula. Right, moving on. Okay, he falls over. He's not a very good skier. Well, his momentum is this. After he falls over, he slows down by sliding across the slope. It takes 2.3 seconds, that's time, for his momentum to reduce to 0. Calculate the force. Okay, the force, look at your formulas, is the change in momentum change in mom divided by the time taken. In this case it's going to be, the change is going to be 2000, take away 0 so it's 2000, divided by 2.3, and that will give me, on the calculator, blah 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 blah, oh gosh, I'm not prepared this morning children, please bear with me, 2.3, oh gosh, equals 869.56 blah 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 blah, 870 newtons. Sweet. Right, let's look at Mark's scheme. Mark's scheme says, what does Mark's scheme say? Right, 1 mark for that, 1 mark for that. Don't miss all these bits out, because if you get the calculation bit wrong, you can still get a mark, okay? And the final question. Andrew is not injured by the fall. Oh, that's nice to hear. Even though he was moving quickly. Use ideas about force and momentum to explain why he's not injured. Right, now then. Okay. I like to do it this way. Force is change in mom over time. So, if we increase time to stop, the force must be decreased. Okay, simple. So we get into Mark's. Let's have a look at Mark's scheme. The force is quite small. We said that the force must be decreased. In fact, we could add on. We could put small there, and blah 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 blah. Okay, because the impact because the impact time is increased. So in simple words, in Key Stage 3 language, big time equals little force. Okay, don't write that on your exam because of this equation here. Right, I'm glad you enjoyed that. Okay, and where's the off button gone now? Gosh, here we go.